Welcome to today's deep dive, everyone. We've got an absolutely fascinating topic to unpack today. We're going to peel back the layers of artificial intelligence to see what's actually running under the hood. I know, for a lot of people, AI can seem like pure magic, right? But today, we're going to completely demystify it. We'll break down exactly how these incredible systems work, from the most basic algorithms all the way up to the modern marvels generating art and text. Think of AI kind of like a matryoshka doll. You know the Russian nesting dolls? You open one layer, and boom, there's another beautifully complex piece inside.
Okay, let's dive into this. Here's our roadmap for this explainer. First, we'll look at AI in our daily lives. Second, the machine learning engine. Third, the three types of learning. Fourth, deep learning and neural networks. And finally, the generative AI era. Let's jump right in.
Section 1. AI in our daily lives. You know, we so often think of artificial intelligence as this distant sci-fi future, robots taking over the world, that sort of thing. But the reality is way more grounded. It's not just a futuristic concept, it's something you and I interact with constantly. If you unlocked your phone this morning with Face ID, bam, you just used computer vision. If you ask Siri or Alexa for the weather, that's speech recognition in action. When Netflix tells you what to binge next, or Amazon suggests a product, they're using pattern recognition, checking Google Maps for your commute, or writing code alongside GitHub Copilot. These are everyday applications anchoring this tech right here, right now, in our present reality.
So, to put it simply, artificial intelligence is technology that allows computers or systems to perform tasks that typically require human intelligence. Think about city traffic cameras for a second. A human can look at a speeding car, recognize the shape of a license plate, and read the numbers. Well, now we have AI systems doing that exact cognitive work. They automatically detect the plate in a fraction of a second and send out a traffic ticket before you even realized you were speeding.
Section 2. The machine learning engine.
All right, we're now peeling back the first layer of our nesting doll to reveal the single most important subdomain of AI today. Because when most people say AI right now, what they're actually talking about is machine learning. And this completely illustrates the massive paradigm shift we've seen in technology. Look, in traditional computer science, you give a machine an input, you explicitly write the program logic yourself, and the machine spits out an output. But machine learning, it flips this entirely on its head. You feed the machine the input data and the historical output data, and the machine figures out the logic itself. It literally learns the rules instead of needing a human to program every single one.
This all happens in two core steps. Step 1 is training. Imagine a bank trying to decide on loan applications. We feed the system thousands of past records, stuff like applicants' salaries, credit scores, and whether their past loans were ultimately accepted or rejected. The system analyzes all this to form a logic model. Then comes step 2, inference. A brand new applicant walks in. The system takes that newly learned model and instantly predicts whether this new person's loan should be approved. It's basically predicting the future based on the past.
Which brings us to Section 3, three types of learning. Now that we understand the engine, let's break down this machine learning domain into its three distinct methodologies. Because depending on the data you have to teach the machine in entirely different ways. The whole field basically rests on three pillars: supervised learning, unsupervised learning, and reinforcement learning. Each one is built to tackle completely different kinds of problems in our digital world.
Let's start with supervised learning. This is when we train a model on very neat, well-structured, labeled data. You are directly telling the machine, hey, this is X and this is Y. A classic example of this is your inbox automatically marking emails as spam or not spam. It also handles regression tasks, so when a food delivery app accurately predicts that your pizza will arrive in exactly 23 minutes based on past delivery times, that is supervised learning at work.
Next up is unsupervised learning. This is where we take the training wheels off. We feed the model raw, unlabeled data and essentially ask it to find hidden patterns entirely on its own. This is exactly how news aggregators automatically sort thousands of daily articles into politics, tech, and sports. It's also absolutely critical for spotting anomalies, like a cybersecurity system instantly freezing your bank account if it notices someone trying to log in from 3 different cities in under a minute. It knows that pattern just doesn't fit.
The third pillar is reinforcement learning. Honestly, you can think of this exactly like training a pet dog with treats. You train an AI agent to interact with an environment. Every correct action earns a mathematical reward, and mistakes get a penalty. The agent's sole goal is to maximize those rewards. This massive trial and error method is exactly how we train AI to win incredibly complex games of chess, or, even crazier, to safely navigate self-driving cars through busy city streets.
Section 4.
Deep learning and neural networks.
Time to pop open the next layer of the doll. Everything we've discussed so far handles standard, structured data really well. But let's be honest, the real world is messy. So what happens when we need to process complex, unstructured data? That's where deep learning steps up. Standard machine learning struggles with things like raw images, video files, or free-form chat messages. Deep learning processes this unstructured data using architectures inspired by the human brain, artificial neural networks. Instead of humans having to hand-code features, these networks automatically extract the crucial elements from messy data. Think about how your phone instantly spots a specific face in a crowded, colorful photograph. That's deep learning.
Now, what's really interesting is how a neural network actually learns. Think of a college calculating student grades. Initially, class tests might have a low weight, say 0.2. But if teachers notice students are skipping class too often, they'll increase that weight to 0.3 to boost attendance, and maybe lower the midterms to balance the whole thing out. Neural networks do this exact same thing just mathematically. They constantly adjust their internal weights over and over until they produce the most accurate possible result.
And this adjustment happens in a continuous loop broken into two simple steps. Step 1 is forward propagation. The network takes the input, pushes it forward through its layers, and essentially makes a guess based on its current weights. Step 2 is backward propagation. The network checks its answer, calculates the loss, which is basically figuring out how wrong it was, and moves backward through the layers to tweak those weights. It is literally learning from its mistakes, millions of times every single second. Because of this, engineers have designed different architectures for different jobs. Feed-forward neural networks are great for simple, one-way predictions. Recurrent neural networks have a built-in memory feature, which is perfect for sequential data like stock prices. Convolutional neural networks, or CNNs, are optimized for images. Instead of getting overwhelmed by millions of tiny image pixels, CNNs use tiny kernels to read small patches of an image, which drastically reduces the computations required. And finally, transformers. They analyze entire sequences for context.
Honestly, transformers are so crucial they deserve their own spotlight. They basically sparked the current AI revolution we're living through. Before transformers, AI read text linearly, step by step. It was slow. But transformers use this brilliant attention mechanism to look at an entire sentence instantly. So if you write, "The dog chased the cat because it was scared," the transformer calculates the relationship between words so it instinctively knows the word "it" refers to the cat, not the dog. It genuinely grasps context. Section 5, the Generative AI Era. We have finally reached the innermost layer of our AI Matryoshka doll. This is the modern technology making all the massive headlines and totally changing the way we work, create, and communicate. So the crucial point here is this. Traditional AI and machine learning have primarily focused on analyzing data, classifying it, or predicting a numerical outcome. Generative AI fundamentally shifts the goalposts. It doesn't just predict, it creates. It can generate entirely new, original text, photorealistic images, dynamic audio, and stunning video from absolute scratch.
Just look at the sheer volume and variety of tasks generative AI can handle today. For text, we're using heavy hitters like ChatGPT, Claude, Gemini, and Meta's Llama. For images, we have Midjourney, DALL-E, and Stable Diffusion conjuring incredible art from just a simple typed sentence. 11 Labs is synthesizing flawless audio voices, Sora is generating cinematic videos from text prompts, and GitHub Copilot is literally writing complex computer code alongside software developers. The scale of this is just staggering.
Now, when you explore these text tools, you're going to hear two buzzwords constantly. Let's define them right now so you can navigate this space with complete confidence. Natural language processing, or NLP, is simply the theoretical field of teaching machines to understand human language. On the other hand, large language models, or LLMs, like GPT-4, are the actual massive models. They're trained on vast amounts of internet data and are actively used to solve those NLP tasks.
Let's step back and see how everything builds a complete picture. As our source material perfectly states, if we are using technology today, then we are actually using different multiple forms of artificial intelligence every single day. From the broad concept of AI, down into the logic-finding machine learning engine, deeper into the complex neural networks of deep learning, and right into the creative magic of generative AI. All these nested layers work together to power our modern digital lives.
Which leaves us with this somewhat provocative thought. With machines now dynamically learning from their own mistakes, adjusting mathematical weights at millions of computations per second, what human task will AI master next? It is a deeply fascinating and rapidly evolving frontier. Thank you so much for joining me on this explainer today. I really hope you found it as exciting to unpack as I did. Be sure to drop your favorite takeaways from this breakdown in the comments below. Keep learning, and I'll see you in the next explainer.